Hi, my name is Stephanie Washer, and we will be going over Module 1, Networking today, which is the first module in the Introduction to Networks version 7, Cisco Networking Academy. At Rock Valley College, we call this PCT 120, and it's basically an overview. We'll go over some new terminology, and we'll do kind of go through things pretty quickly because we will expand on it in other chapters or modules. So the objectives for this module, we're going to look at how the networks affect our daily lives. I'm going to go through that so quick, it's not even funny. How hosts and network devices are used, network representations and how they're used, common characteristics, LANs versus WANs, the 4 requirements of a reliable network, any trends. Usually there's more things than what is on this slide, and then some security threats. And then finally, we'll do a real brief overview of employment opportunities in this field. So in this video, we're going to go through probably the top 4. So 1.1 through 1.4. It's so that the video isn't very long. And then we'll split it up and do 1.5 through 1.9. So 1.1, networks affect our lives. Well, we know this, right? With everything going on right now, we're living in a pandemic where we have school online, and at Rock Valley we just had a tornado over a week ago that caused damage to our building and caused us to do a lot of things online and do different things differently online because of the fact that we couldn't reach our equipment in our classrooms or our online lab equipment. So we're just doing things a little bit differently, and we have discovered that communication and connection to all of our devices is extremely important. Luckily, we had other ways around it for us. There is a video on the Cisco Networking Academy and how to use it in the learning experience. So you can go and look at that in Module 1.1. And just another picture with we know that you can get cell service, you can get information anywhere. It is nice to go on vacation and not have cell service to be bugged, but it's a global network without boundaries, and that is 1.1. So we'll go on to 1.2. I mean, 1.1, everybody has experience with it. If you have any questions on it, let me know. But in 1.2, we'll talk about the different components of a network. And in Cisco and in networking, every computer on the device is a host or an end device. So when I say host, I usually mean a computer. Node might be like it could be a computer, but it also might be like an IP phone, just depending on different things. So, but right now, host or end device is a computer on a network. And there is what's called the client-server network. We're not going to go into that in huge detail, but basically it's the client asking for information from a server. And it could be over the internet, it could be however. And the different types of servers, there's more than this obviously, but these are, just a simplistic table. You could have an email server, a web server, or a file server. If I need to go to, like Google Drive, if I have to go and get a file from somewhere, maybe I have a file that I'm sharing, maybe it's not on Google Drive, but maybe it's a shared file through Rock Valley College, through our services. I might have to go to the file server and contact that file server to get whatever file I need. So this PowerPoint is uploaded onto a server and I can go get it. Web page, we're just always on web pages, right? So all it is just the client contacting a web page to get information off of it. And then our email server to get our email information. Right now, email is really important. It's the only way that I have been communicating with people from work, really, other than Zoom. So then we have peer-to-peer networks. So client server, we have a client that asks a server for information, and it really is more complicated than that, but to make things simple, we'll just leave it at that. And then we have peer-to-peer where everybody's on the same level. And they are, one computer can be hooked up to the printer and be sharing its its printer, and then it will use the peer-to-peer file sharing. Another computer could be sharing files. So it's just that peer-to-peer network is just so much easier to set up. Really, there really is hardly any setup. All you have to do is just turn on sharing. The thing about peer-to-peer network is if your computer is hooked up to the printer and you're sharing the printer, that computer has to be on. If it is not on, you will not be able to share that printer. That's what is nice about a client-server network, where you have a server that is centralized and it's taking care of all the administration and it stays up all the time. You don't have to worry about some random person, not random person, but someone leaving for the day or having a day off and their computer not being on and then you not being able to use the printer. So it's just nice and easy to have the centralized administration of the client-server network. The advantage of peer-to-peer is it's easy to set up. Most people probably have them at home. You don't have centralized administration, which is a disadvantage, but it's less complex, easy to set up. Obviously, there's a lower cost to it because you don't have to have a server. And then you just use it for simple things like sharing printers and sharing files. So the disadvantage is it's not secure, it's not scalable, it's not for large environments, and it's lower performance. End devices. So as I said before, end devices are the computers. We have a little picture here where information can flow through the network and go from one end to the other. This intermediate network has routers and probably switches in there too, and those would not be end devices. So all of these here where the information ends, so at the server, the computer, a laptop, IP telephony, IP phone, those are all end devices. And then the information flows through the network to the end device on the other side. These are the intermediary devices. So the thing about this is when we use Packet Tracer, because in Cisco we definitely use Packet Tracer, it's a really great program, and it comes free with our class. These are the icons that you will see in Packet Tracer. Not necessarily the computer people, but the devices. So on this one, these are the intermediary devices. We've got our wireless router, LAN switch, router. In Cisco One, we are mainly concerned with LAN switch and routers for right now. We won't be seeing this as much, maybe a wireless router here and there, but we have multi-layer switch and a firewall. So any of these intermediary devices, they are the items that are interconnecting the end devices. So some of them, what they're going to end up doing is, as it says here, you regenerate and retransmit signals, data signals, so that they can be carried across the network. And it's going to figure out best path. And then if there's any errors or any communication failures, it is going to notify the devices and try and rectify the errors. Network media. This is just the media. This is how you're connecting. And so whether it's wireless or copper or fiber, you're going to have that information carried across that medium. And we have multiple modules on how all of this works and how the information is carried across it. So now the fiber, we're going to go into more detail about fiber, but it's glass or plastic within cable, and it uses pulses of light. The Cat5 or the copper, or Cat6 even, metal wires within cables, and it uses electrical impulses. And then wireless, we just use electromagnetic waves. So that was the quick of the network components, and now we're going on to network representation and topologies. This one's real quick. There's just 2 slides. I like this slide because this is gives you a visual representation of what you're going to see in Packet Tracer. Mainly we use desktop computers in Packet Tracer. You don't see some of these other things, but these are what the end devices look like in it. Same with the intermediary, that's what you're going to see. And then the network media, that's how it looks in Packet Tracer as well. So what we need in the topology diagrams is we need an end device, we will use an intermediary device, and then we'll have some sort of network media to connect it all. So on the desktop computer or on the switch or router or whatever, you're going to have a network interface card, a NIC. And in that, you know, they put these in, it looks like a network interface card is an interface and it is a physical port. So on the desktop computer, you have a network interface card, you have a physical port basically that you can plug into. On the switch and router, it's going to be an interface. Depending on what the interface number is, you'll see how that we'll program them. In one of the commands, we actually use the term interface to program the exact interface on the switch or router. So sometimes they are used interchangeably. That's the thing with networking and computer sciences. Some of these terms are used interchangeably. I always say there's one term, there's not just generally one term. It's like there's 50 ways to describe something. So, but generally most of the time I'll use the term NIC or interface because that's how you program the router. And you'll see later on how we get to that. So these are topology diagrams. These topology diagrams are a little more complicated than what you're going to see in Packet Tracer right away or in our labs. We're only going to program like 1 or 2 routers at the most, so or 1 or 2 switches. So at the most you'll see 2 switches, 2 routers, and probably 2 computers. So we have the difference between, there is what's a physical representation and there's a logical representation. So the physical representation is how it's physically cabled in the building. And so you can see we have a server room here, and this is how everything is connected. We've got the web server, email server, and the file server all connected on to switch 1. And then switch 1's connected to R1. And you can even see what shelf each device is on and what room each device is in. So you can see all of that on our physical topology. But on our logical topology, it's set up a little differently. They're going to be on different networks. They might have special VLANs for certain activities. So it's going to be a different, and you can see here that it is somewhat of a different topology. So we've got how everything's connected and then how everything is logically placed in their subnets and addressing schemes. We're going to go on to common types of networks. And this is going to be the last portion for this mini lecture. So we have different size networks. We have, our small home office that might have a wireless router and then multiple devices that are connected to that. My wireless router, I have a physical desktop plugged into it and a wireless, I have a wireless printer, and I have 1, 2, 3, 4, 5, 6, I think, 6 or 7 different tablets, phones, laptops that connect to it. Oh yeah, there's probably 8, but my Surface Go had a little issue and the hard drive died, so that one's out of commission right now. So small home network, we are familiar with that, very familiar. And then there's the small office, home office, or SOHO. And basically, it's just a remote office or a small office within a house that connects to a corporate network. So it's kind of like a little mini branch, just kind of off to the side. And then we have a medium to large network with locations all over the place. And all of those computers are interconnected. And then worldwide, obviously connecting all of the computers and everything worldwide, just like we have on the internet. So there's a difference between a local area network and a wide area network. So we have local area network, wide area network. So LAN versus WAN, and it's just basically size. So a LAN is a smaller area, and you can see that the LAN are in, I don't know, tan, whatever you want to call that color. And they're just, the biggest thing is, this is a smaller area, but it's got a boundary. And so right here is a router that's probably the boundary router. And you always have like a gateway to the outside world. In Cisco, in this class, sometimes gateways can be a server, but in this instance, or a firewall or whatever, in this instance, we're always going to have the the router, the intermediary router, or the router that's directly connected kind of like to this network is going to be a gateway, and we'll talk about gateway again later. So we have our home office, we have our branch, and we have our central office, and it's all connected with the internet in between. And this is the WAN. The internet in between is the WAN. We don't really know what's going on in here, but we know that there's computers connected to computers, connected to computers, connected to routers, connected to switches, you know, just everything all over the place. So here's a good description of LAN is in a limited area, while WAN is large geographic. LAN is a single organization or individual takes care of the infrastructure. WAN is definitely more than one person, more than one company. LAN has high-speed bandwidth to internal devices, and WAN is probably going to be lower speed because it's outside. You know, we are getting more and more higher and higher speeds, but within the LAN, it's definitely higher speed than out in the WAN. And in the WAN, you don't know what speed you might have. So, you know, across the WAN, we don't know what everybody else's speeds are. We have the internet. So it's just LANs that are connected to one another, basically. And it could be copper, it could be fiber, it could be wireless, it could be anything. And so in that area where we have different ways of transmitting and different ways of communicating, we always have protocols and standards that we follow to help maintain the structure of the internet. And we'll talk about all those protocols. It's one module all on its own. One last item to go over about types of networks is there's intranets and extranets, and we have there is a possibility that at your company, you know, we have the internet, everything in the outside world, we can get to everything, everybody can get to it. But then we have maybe an internal network that only company people can get to, and you might have to use a VPN to get into it, and we'll talk about VPNs later too. Or you might even have an extranet, which is a protected network that only suppliers and customers and people that you want to collaborate with are allowed to get into. So we have intranet, internal private, and then we have extranet, which is internal and private, where you provide access to the outside individuals that you want to access your network. And then the internet is everybody can get a hold of everything. So that is sections 1 through 4 in Module 1 of Cisco Networking Academy, Introduction to Networks.